talk about a suspended mass. In this case, we've got a traffic light suspended by two cables as shown, and we'll label them T1 and T2. We've measured the tension in the cables using a spring scale, and we found that T1 is 49 newtons and T2 is 85 newtons. Can we find the mass of the traffic light? And of course, the answer is going to be yes. Let's start off by drawing our free body diagram. X and Y. Now, there's our object. Of course, we have its weight, mg down. We have tension 1, T1, and if I do just a little bit of geometry over here, if that's 30 degrees, that must be 30 degrees. And over here, if that's 60 degrees, that's 60 degrees. So I'm going to draw T1 that direction at an angle of 30 degrees, and T2 over here at a bigger angle at 60 degrees. So my pseudo free body diagram, I've got to break up T1 and T2 into their components. Make our free body diagram again. Y, X, or axes again. Now mg, of course, still points down. Let's start with T2 here. Its x component is going to be T2 cosine 60, so I'll have here T2 cosine 60 degrees, and its y component will be T2 sine 60 degrees. Now let's deal with T1. Its x component will be to the left, and that's going to be T1 cosine 30 degrees, and its y component, T1 sine 30 degrees. All right, if we're trying to find the mass, I'm going to start with Newton's second law in the direction that has the mass in it. So I'm going to write F net equals ma, but I'm going to look in the y direction. And I'm going to replace F net y with all of the forces that I see over here acting in the y direction. So F net y is going to be equal to, I've got T1 sine 30 degrees pointing up, plus T2 sine 60 degrees, and I have mg down, minus mg. And we know that all of that, since this is just sitting there, the traffic light's not accelerating, it must be 0. So that's all equal to 0. Well, when I do that, I can then say, since T1 is 49, that 49 sine 30 degrees plus T2 is 85 newtons, 85 sine 60 degrees, must be equal to mg. Or 49 sine 30, that's about 24.5, plus 85 sine 60, that's around 73.6, must be equal to mg, 9.8 times m. Divide both sides by 9.8, and I come up with a mass of about 10 kilograms. Newton's second law, F equals ma, and free body diagrams and pseudo free body diagrams to help us apply those concepts. Terrific tool we're going to use all the time here in physics. Hope you've had a great time here at Educator.com. Make it a great day. We'll talk to you soon.